Some series to integral calculus. Some series through integral calculus. This is what the kind of series that we have started. Can we calculate some series through integral calculus? Is it really a practical way? Is it really possible? Calculating the sum series through integral calculus. Anyway, what sum series that we are calculating? The sum series that we are calculating is 2x minus 1. 2x minus 1 is 1 plus 3 plus 5 plus 7 plus 9. I mean, there is a sum series called 1, 3, 5, 7, 9, 11. Someone would say, look like this is an odd number. Yeah, this is odd number. If this is an odd number, then what is summation of series for n number of terms? Okay. What is the summation of series for 3 number of terms? Then it is 1, 3 and 5. Then it will come as 9. Anyway, what is the summation? What is the summation from the first 6 terms? First 6 terms. 1, 3, 5, 7, 9, 11. These are the first 6 terms. So these are the first 6 terms that is the summation. What is the summation of first n terms? That is the question. What is the summation of the first n terms? Can someone compute it? There can be many algebraic way to compute it. Problem is that if someone try to calculate the summation of a series through algebraic way, then for each different series there are different ways, and someone has to remember separate way for separate summation series. This is what I am saying. If there are 1000 type of series, then 1000 ways someone has to remember how to compute the formula for a series. What is the formula for a series when it is 1 plus 3 plus 5 plus 7 plus 9 like that? What is the formula of a series when it is 1 plus 2 plus 3 plus 4 plus 5? What is the formula of a series when it is 1 square plus 2 square plus 3 square plus 4 square plus 5 square? What is the formula of a series if it is 1 by 2 plus 2 by 3 plus 3 by 4 plus 4 by 5 like so? What is the formula of a series when it is 1 by 2 plus 1 by 3 plus 1 by 4 plus 1 by 5 plus 1 by 5? What is the formula of a series when it is 1 by 1 whole square plus 1 by 2 whole square plus 1 by 3 whole square, 1 by 4 whole square? There can be innumerous summation series, and there are innumerous way to find the sum summation series. Innumerous way. Can someone remember the innumerous way to calculate the sum summation series? Means that's why we are bringing in calculus. This is the era where the dependency on computer is very high. Everyone wants to calculate everything through the computer or calculator or whatsoever. But summation of series or through calculator is not possible. Neither through computer is possible. Means if someone wants to write summation of what we are saying now, 1 plus 2 plus 3 plus 4 plus 5 up to 10,000, and how many times he will type 1 plus 2, 1 plus 3 plus 5 plus 7 plus 9 plus 11, then he will die only. Then he has to write one algorithm or whatsoever. That is another tedious job. How if I have a mobile, if I have mobile in my hand, then how I can type an algorithm and those? Not possible. Through computer or through calculator in mobile, this kind of series summation is not possible. Someone has to take pen and paper, and he has to come through a formula, and for each summation series formula is different. The way formula is deduced for each summation series it is different. Not possible to calculate through a unique way. Okay, what I'm trying to say, if someone is saying, can you recognize voice? Okay, can you recognize voice? This voice is coming through one particular channel, or one person is speaking, another person is speaking. Can you recognize that which these two person are? Can you recognize? Okay, okay, there is a voice algorithm through which probably someone can recognize, or I can say there are two voices that is coming out of the loudspeaker. of the out of the loudspeaker, two voices are coming out. Okay, now you hear these voices. Now there are 10 people sitting here. Now say these two voices belong to which two people among the 10 people. Okay, this is one scenario. Someone will start analyzing into the audio algorithms and this and that, and he will scratch his head for months or years to find out the algorithm where it will match the voice. Now someone is saying, consider I have two specimens of signature, or I would rather say, I'll ask two persons to sign on a paper. They sign on a paper. Then 10 people are sitting here. Okay, I have taken the kind of signature of 10 people. Among them, these two people are also there. And 10 signatures are there. Can you say these two signature matches to which two people? Similarly, now someone will start running behind the image processing software. How many software you will process? Video processing software, image processing software, voice recognition software. There will be 1,000 way to recognize this kind of data. Is there any generic algorithm? I don't know. Personally, I don't know. But anyone has to invent one generic algorithm. That algorithm will identify to voice sample. That generic algorithm with same algorithm. Same algorithm. I have to just take photograph of signature and pass it to the algorithm. I have to take snapshot of the voice and pass it to same algorithm. I have to take video snap and then after all will come as a byte data only. Then pass it to the algorithm. Algorithm will take it as a byte data only. Either it is a voice sample, image sample, video sample, whatsoever. And then it has to identify similar images. There are many requirements for this matching. As far as matching requirement is concerned, there can be many scenarios. Okay, okay, like consider that someone has to identify a smell. At least there is no, I believe, there is no transducer which will identify the smell so that it can convert a smell that is coming to byte code. I don't think so. But if someone invent, then can you find the similar smell? That can be another requirement. Like so, there can be many requirements. Okay. Now, at least for the sum and summation series, we have invented that there can be a way through integral calculus. Someone can calculate all possible summation series through a generic way. And what is the generic way? Through that we are in the previous video. Okay, we calculated the summation series of 1 plus 3 plus 5 plus 7 plus 9 like so, and it came as n square minus n square minus n in general fashion. And then we felt it is not complete. If I place n square minus 1, there are two ways to calculate the summation series into integral calculus. One is called repeated summation, and another is called through successive approximation. Repeated summation means whatever the requirement is, if I have to calculate add of a series that is 1, 3, 5, 7, 9, 11, I up to n terms, not up to 11 and n, up to n term, where 11 falls as a sixth term up to n term. Then we divide n term into n different parts, and we make sure that each part looks same. Then each part will look same if I identify each part as 2x minus 1, where x is variable. So 1 is 2x minus 1, 3 is 2x minus 1, 5 is 2x minus 1, 7 is 2x minus 1, 9 is 2x minus 1, 11 is 2x minus 1. More or less, I can say 2x minus 1 terms x time. 2x minus 1 dx from 0 to n. This is repeated summation. Please watch our previous video. And then it will come as x square minus x. 0 to n square minus n as the summation. This is what we are receiving through successive, through the repeated addition. There is another way called successive approximation. Successive approximation, we have demonstrated it many times. I'll do it again. Successive, successive approximation. Okay, successive approximation falls in a way that what we are trying to calculate. We are trying to calculate 2x minus 1 plus 2x minus 1 plus 2x minus 1 when x is varying. First 2x minus 1, x is 1. Second 2x minus 1 is x is 2. 2x minus 1, x is 3. This is what I am saying. Okay, if that is the case, then I can rewrite as sigma sine fx, sigma sine fx, and then x is 1 to n. Fx is 2x minus 1, means 2x minus 1 plus 2x minus 1 plus 2x minus 1 n times, where first 2x minus 1 is x equal to 1, 2x minus 1 next time x equal to 2, 2x minus 1 third time is x equal to 3, like so. Last time x equal to n, what it is? Sigma sine x equal to 1 to n, function over x. Function over x is 2x minus 1, can be computed. Okay, repeated approximation says that consider this is fx. Consider consider this is fx. This is fx, means when x equal to 1, the height is 1. When x equal to 2, height is 2. This is a straight line. Repeatedly I say, this is a straight line. Because 2x minus 1, y equal to 2x minus 1, or fx equal to 2x minus 1, if I differentiate, it will come as 2. Fx equal to function over x equal to 2x minus 1 dfxy by dx will come as 2, means slope is constant, so it will be a straight line. This this is typically fx, this is typically fx equal to 2x minus 1. When x equal to 1, height is 1. When x equal to 2, height is 3. When x equal to 3, height is 5. When x equal to n, height is 2n minus 1. Okay, this is the equation. Now I have to add all the vertical bar at x equal to 1. This axis is function over x or y axis. This axis is x axis. This is a straight line and its equation is function over x, that is 2x minus 1, and this is a discrete function. This is not a continuous function. Discrete function. How this function is generated is I took at x equal to 1, this is x axis. Many times we have talked about this is x equal to 0, x equal to 1. If this is x equal to 1, then I have a height vertical bar at x 1. When x equal to 2, vertical bar is 3. When x equal to 3, vertical bar is 5. When x equal to 4, vertical bar is 7. If I add all the top point of this line, then it will form a straight line, and that straight line I am calling function over x. Okay, so function over x is 2x minus 1, but I have to calculate all the summation of all the vertical, means summation sigma sine x equal to 1 to n, function over x, where function over x is 2x minus 1, means 2x minus 1 plus 2x minus 1 plus 2x minus 1 n time. First x is 1, next x is 2, next x is 3, like so. Okay, now what the concept is considered, I have another function called gx, and gx is a continuous function. Fx is not a continuous function. Fx is a discrete function, and it has a value at x equal to 1, 2, 3, 4. Only at the whole number it has the value. Otherwise, in the fraction of x equal to 1.1, 2.5, at this point there is no fx at all. This is a discrete function. Can I imagine? So there cannot be any calculus over fx now, because if I do differentiation, then it needs to contiguous point, two contiguous point where I can have delta y by delta x, then I can go for differentiation. If I try integration, then there had to be two contiguous point along x-axis, x equal to one point, x equal to another point. If I take these 2 points, it will hit on a line where between these 2 point line is completely connected. Fx dx will give area between these two. But fx is not a continuous line. If we saw fx as a straight line, then it is point. This is also called point mass function. There is another function called gx, and gx is a continuous line. If gx is a continuous line, then what we are trying? We are trying to add all the verticals. There are many verticals. First vertical is of height 1, height 3, height 5, height 7, height 9, height 11 at x equal to 1, 2, 3, 4. Okay, if I take x equal to 1 and x equal to 2, these two portion, and if I go like this, then it will hit gx. Gx is a continuous function, and this is the area between x equal to 1 and x equal to 2. Then it can be written as integration x equal to 1 to x equal to 2 gx dx. Gx dx is the area between these 2 points. Gx dx between x equal to 1 and x equal to 2. Make sense? This is the sub area between x equal to 1, x equal to 2, gx dx. Okay, what is this sub area? This sub area should be exactly same as fx at x equal to 1. This is what I am saying. Means the sub area that is found between x equal to 1 and x equal to 2, this sub area should be exactly same as fx at x equal to 1. Means this sub area in gx belongs to fx at x equal to 1. When fx is x equal to 2, that is height is 3, then this height 3 should be matched to gx dx between 2 to 3, this sub area. Each sub area in gx is same as whatever is the height on the left side of fx. What I am trying to say, consider there is any point here called x, any point x. If this is point x, then what is fx at this point? This is fx. The fx at this point is 2x minus 1. What is gx dx at x equal to x? Then x equal to x and x plus 1. What is the area between this up to gx? This area should be exactly same as left hand side. What is fx? I mean fx equal to integration x to x plus 1 gx dx. If this holds true, if this holds true, then we have found gx. If I found continuous equation gx, so that if I take any area strip between x and x plus 1 to gx, this area strip should be exactly same as if I take left side. This is right side, this is left side. Left side is x and right side is x plus 1. If I take x, then what is fx at that point? That is 2x minus 1. This height should be exactly same as this area strip in gx. In that manner, all the heights in fx will be same as right hand side area strip. Make sense? Means if I say summation x equal to 1 to n fx, then it will be equal to 1 to 2 gx dx plus 2 to 3 gx dx plus n to n plus 1. Last will be n plus 1. N to n plus 1 gx dx. If I say there are three vertical at x equal to 1, 2, 3, the vertical are 1, 3 and 5. Okay, in that manner, if I say if there are three vertical, then there are three sub area. One sub area is between 1 to 2, next is 2 to 3, and third will be beyond 3, 3 to 4, n to n plus 1. Means more or less I am saying summation x equal to 1 to n fx equal to limit 1 to n plus 1 gx dx. If someone is calculating it, then he can get the full summation provided he knows the gx. To know the gx, we will take any x equal to x. What is fx? This fx height at any x equal to x. What is fx? 2x minus 1. This 2x minus 1 should be exactly same as x to x plus 1 gx dx, this sub area. If it is like so, we find the gx. Okay, or someone can try left hand side. If x to x minus 1 or x minus 1 to x, if this sub area is same as right hand side fx, then again we find new gx. Or before and after of x, x minus 0.5 to x plus 0.5. If this is the sub area in gx, this will be exactly same in between fx. Any three you can try finding gx separately. All three methodology, right hand side, left hand side, or in between, all three methodology, gx will come differently. But at the end, if I place the integration and limit, the net result should come the same. Means all the vertical addition should be exactly same as gx dx area. Then we found the way to calculate the summation of the series. So let's start with the right hand side. If I take right hand side, then fx equal to x to x plus 1 gx dx. Fx is 2x minus 1. 2x minus 1 equal to limit x to x plus 1 gx dx. Fx equal to gx dx. Dx equal to dfx by dx. Okay, fx is 2x minus 1. dfx by dx will become 2. 2x minus 1 differentiation would become 2. We'll try gx as 2. 2 integration is 2x. 2x, x to x plus 1. That will come as 1. 2. It will come as 2 only. Left hand side, the need is 2x minus 1. After placing the limit at x equal to x, it should come as vertical at 2x minus 1. But it is coming as 2. 2. So I have to multiply by x. Let's settle down x term, then we'll see the constant. So I have to multiply by x. We'll start with 2x now. This is called successive approximation. Step by step, we are approximating it that we have to come true. In that manner, we will try again. So x to x plus 1, 2x dx. Then it will become 2x square by 2. 2 gone, x square. X square from x to x plus 1. Then x plus 1 whole square minus x square. Then it will become x square will go away. 2x plus 1 exactly. Left hand side 2x minus 1. Right hand side we are getting 2x plus 1. Means how I can get 2x minus 1? I have to subtract by 2. Then it will become 2x minus 1. So whatever we did, we'll subtract with 2 and we will try again. No harm in trying. If I try again 2x minus 2, here is 2x minus 1, but here it is 2x minus 2. 2x minus 2. We'll try 2x minus 2 integration will be x square minus 2x. Okay, x square and limit is x to x plus 1. If I settle down x square x to x plus 1, it will come as 2x plus 1, the way we saw earlier. X plus 1 whole square minus x square. It will come as 2x plus 1. We have minus 2x. Minus 2. Minus 2 integration will be minus 2x. Minus 2 I can keep outside and we will settle down x to x plus 1. Then it will come as 1 minus 2. So this side we have 2x plus 1 minus 2. 2x minus 1. Both are exactly same now. Fx means the vertical bar at x equal to x is 2x minus 1. Whereas right hand side area is 2x minus 1 again. Again, if I take gx as 2x minus 2. Now for fx as a discrete function, that is 2x minus 1, I can say there is a continuous function gx and that is 2x minus 2, and if I calculate the area underneath it 2x minus 2, then it will be same as what we are doing, the addition of vertical. Okay, I believe it is alright. What is addition of vertical? That is summation x equal to 1 to n fx. Fx is 2x minus 1. It should be equal to, from lower limit that is 1 to higher limit n plus 1. 1 to n plus 1 gx dx both will be same. So we can find the solution now. We'll try again. Gx is 2x plus 2. 2x plus 2. So we'll try integration. It will come as x square plus, oh I'm sorry, 2x minus 2. Okay, we'll try. It will come at x square minus 2x. Okay, I have to put 1 to n plus 1. 1 to n plus 1. N plus 1, not n. Summation is x equal to 1 to n fx. But here it will be 2x minus 2 dx integration from 1 to n plus 1. X is 1. That is the starting point, whereas end point will go n plus 1. We'll try. So it is 2x integration will be x square minus 2x from 1 to n plus 1. If I settle down n plus 1, then it will become n plus 1 whole square minus 2 n minus 2. I think so. Minus 2 integration will be minus 2x. Minus 2x. If I x instead of x, in place of x, if I put n plus 1, it will be minus 2n minus 2. So it is n plus 1 whole square minus 2n minus 2. N plus 1 whole square will become n square plus 2n plus 1. This is what I think so. Okay, n square plus 2n plus 1. And here I have minus 2n minus 2. Minus 2n plus 2n gone away. And we have 1 minus 2 minus 1. N square minus 1. This is what the result is. N square minus 1. Now we have lower limit as 1. That we will settle down. Okay. Now we have integration that came is x square minus 2x. Okay. Now minus I'll keep outside because lower limit is there. Minus outside, or it will come as minus x square plus 2x. Minus if I settle down. Minus x square plus 2x. Minus 1 plus 2. Minus 1 plus 2. It will come as 1. 1. So net result that will come as n square plus 1 minus 2 plus 1. That minus 2 plus 1, it vanished and it came as n square. So is it what the summation of 1357 is n square? Can someone believe that n square? N square means it is a square. Square. Personally, I can't believe it. It is a square. We'll try now. Let's say n equal to 3. Then 3 square, it should be 9. 1 plus 3 plus 5 is 9. N square. N square means if I take n equal to 6, then summation should come as 36. 1 plus 3 plus 5 is 9. Plus 7 is 16. Plus 9 is 25. Plus 11 is 36. 36. If I take n as 9, then it should come as 81. 81. 9 means 9 term will how much it will go? 1, 3, 9 term will go up till 2x minus 1. Up till 17 it will go. Anyway, up till 6 it is 36. Oh, sorry. Up till 7. Up till 7 it will go up to 17. So up till 7 I think up till I forgot. 1 plus 3 plus 5 is 9 plus 7. Yeah, plus 7 is 16 plus 9 is 25 plus 11 is 36. Up to 11 we have added. 36 plus 13. 36 plus 13 is 49. 49 plus 15 is 64. 64 plus 17 is 81. So perfect n square. Okay, we will see other two way. This is called successive integration. We start with integration as dx equal to d fx by dx, and from there looking at the difference between fx and dx x to x plus 1, we try settling down with dx so that end result should be same, and then we found the dx, and we will try 1 to n plus 1. Now if I this we have taken right hand side, means I'm really sweating. These are very tedious to get. Looks like very simple. So we tried right hand side. If this is fx, then we took gx x to x plus 1. We can try left hand side. Means fx equal to integration x minus 1 to x gx dx. Then I have to find gx, and that will be different. Then we will try. If I have fx, then x minus 0.5 to x plus 0.5, then area. Then summation of all sub area it should become. Then left hand side will finally it will go as 0 to n. Middle will go as 1 minus 1 by 2 to n plus 1 by 2. Left hand side will go 1 minus 1 to n. Next two style we will try. If it really comes n square, if always it comes n square, then our solution of n square is perfect. Because after all we took successive approximation and we tried to find out continuous function gx, considering gx is divided into n sub area and each sub area is equal to one vertical bar. I can divide this into left hand side sub area, right hand side sub area, or central sub area, whatever. But it should be same. Gx will vary with the three different approaches that we will see. We will finish left hand side and central side. I'm really sweating. These are really very intricate. If someone cracks this minute concept in calculus, he can crack partial derivative, multivariable calculus, multivariable, multi-order differential calculus, so many things. Minuteness people they do not understand. Otherwise, everything is very easy. Please do not mind supporting us. +91 is the India country code 9483160610 is the telephone number. +91 is the India country code 9483160610 is the telephone.